For decades, black holes have captivated the imagination of both scientists and the general public. These mysterious cosmic entities possessed an immense gravitational pull that nothing, not even light, can escape. However, the inner workings and nature of black holes have remained shrouded in uncertainty. Recently, renowned theoretical physicist Michio Kaku made headlines with his assertion that we have finally made a breakthrough in understanding what lies inside a black hole. In this video, we will delve into Kaku's revelations and explore the implications of this groundbreaking discovery for our understanding of the universe. The enigma of black holes. Black holes are regions in space where gravitational forces are so strong that they create a singularity, a point of infinite density at their center. Surrounding the singularity is the event horizon, a boundary beyond which nothing can escape the black hole's gravitational pull. Until recently, the nature of what lies within this enigmatic region has remained a subject of intense speculation and theoretical inquiry. Enter Michio Kaku, a theoretical physicist known for his work in string theory and popular science communication. In a recent series of lectures and interviews, Kaku boldly claimed that we have finally gained insights into what lies inside a black hole. These revelations are based on advancements in theoretical physics and the utilization of powerful mathematical tools. Understanding the inside of a black hole. According to Kaku, the key to understanding the inner workings of black holes lies in the framework of string theory. String theory posits that the fundamental building blocks of the universe are not point-like particles but tiny vibrating strings of energy. These strings give rise to different particles and forces depending on their vibrational patterns. Kaku suggests that when matter collapses into a black hole, it becomes entangled with these fundamental strings, forming a hologram that encodes the information of the matter that fell into the black hole. This holographic principle implies that all the information about the matter is preserved on the black hole's event horizon. Traditionally, it was believed that once matter crosses the event horizon, it is lost forever, leading to the concept of the information paradox. However, Kaku's recent insights suggest that the information is not lost but is imprinted on the black hole's surface in a two-dimensional form, much like a hologram. This finding is in line with the principles of quantum mechanics where information is conserved and cannot be destroyed. Moreover, Kaku proposes that the interior of a black hole, which was once thought to be an incomprehensible singularity, might actually be a wormhole or a passage to another universe. This notion aligns with Einstein's theory of general relativity, which allows for the existence of wormholes that connect distant regions of space-time. Implications and future directions. Kaku's breakthrough in understanding the interior of black holes has profound implications for our understanding of the universe and the laws of physics. It challenges long-held notions and opens up exciting avenues for future research and exploration. One of the most significant consequences of this discovery is the resolution of the information paradox. If information is indeed preserved on the black hole's event horizon, it implies that black holes are not the ultimate information destroyers as previously believed. This finding aligns with the principles of quantum mechanics, which emphasize the conservation of information. Furthermore, Kaku's proposal of black hole interiors as wormholes or gateways to other universes has implications for the study of multidimensional spacetime and the possibilities of interuniversal travel. While these ideas remain largely speculative, they stimulate further investigations into the nature of black holes and the potential existence of parallel universes. Additionally, Kaku's revelations highlight the deep interplay between string theory, quantum mechanics, and general relativity. These fields of physics have long been regarded as separate and sometimes conflicting, but the understanding of black hole interiors may provide a unifying framework that reconciles these theories. This progress could potentially lead to a more comprehensive theory of everything, a long sought-after goal in the realm of theoretical physics. However, it is important to note that Kaku's insights are still theoretical and require further empirical evidence for validation. The extreme conditions inside black holes make direct observations challenging, and current technological limitations hinder experimental verification. Scientists will continue to rely on mathematical models, computer simulations, and future advancements in observational techniques to validate or refine these theories. Michio Kaku's assertion regarding the understanding of what lies inside a black hole represents a significant milestone in our quest to unravel the mysteries of the universe. His insights, based on the principles of string theory and the holographic principle, challenge traditional notions of black hole interiors and offer potential resolution to long-standing puzzles such as the information paradox. While Kaku's ideas are thought-provoking, they remain theoretical and require further investigation and empirical validation. The continued advancement of theoretical physics, coupled with technological advancements, holds the promise of unveiling the secrets hidden within black holes and deepening our understanding of the fundamental nature of the cosmos. So that's it for today. If you like this video, then please hit the like and subscribe button. For more videos, thanks for watching.